Skyscrapers are more than just tall buildings. They're statements of power, ambition, and imagination. But some towers push those limits so far, they almost shouldn't exist at all. From gravity-defying designs that twist into the sky, to ultra-skinny towers swaying in the wind, to forests suspended hundreds of feet above the ground, architects and engineers have turned wild dreams into jaw-dropping realities. Today, we're looking at some of the strangest, most impossible skyscrapers ever built. These are structures that defy convention, challenge physics, and completely rewrite what a building can be. American Copper Building, New York, USA. New York has more skyscrapers than Beijing, Seoul, and Toronto combined. Only Shenzhen and Hong Kong surpass it, leaving Manhattan packed so tightly with towers that new projects often demand highly inventive solutions. Over the years, we've seen pencil-thin supertalls, towers stacked on top of existing buildings, and even skyscrapers balanced on stilts. But nothing quite prepared the city for what rose on the banks of the East River. The site itself was a puzzle. A protected park sat on one side, a planned schoolyard on the other, and just two narrow footprints remained available for development. Building two towers separately would waste potential, but combining them seemed impossible. The architects came up with a daring solution: lean the towers toward one another and connect them in the middle with a bridge. This idea became the American Copper Building, two slanted skyscrapers joined by a three-story sky bridge that instantly became one of the most distinctive silhouettes in the city. The bridge itself was a challenge unlike anything New York had ever seen. Instead of fixing it rigidly, engineers had to let it move. It was anchored firmly to one tower, but allowed to glide on massive Teflon plates on the other. That way, when the wind makes the skyscrapers sway, each tower can shift independently without ripping the bridge apart. Inside, the bridge was more than just a connector. It became a centerpiece, housing lounges, a gym, and even a swimming pool 300 feet in the air where residents could literally swim from one building to the other. But the problems didn't stop there. The construction site sat barely a meter above the East River, and the water table threatened to flood it before anything could rise. To solve this, crews dug the foundations inside a watertight concrete bathtub. Pumps worked around the clock for over a year, removing nearly 1.5 million gallons of water every single day just to keep the ground dry enough to build. Only after that could steel and concrete climb skyward. Then came the structural drama. Because the towers were designed to lean inward, their appearance fooled people into thinking they were collapsing. Passers-by reported them as unsafe, and even the fire department demanded to see the blueprints to make sure the project wasn't a disaster in the making. To calm fears, engineers had to explain how the tilt was intentional and carefully balanced. Finally, there was the choice of skin. Covering the entire facade with over 4 million pounds of copper was a gamble. No other skyscraper in the city had ever been fully clad in the metal. At first, the orange glow of raw copper made the towers stand out like burning embers on the skyline. Over time, it will slowly darken, then eventually turn into a green patina like the Statue of Liberty, giving the building a living, evolving character that no other high-rise in Manhattan can claim. Through all of these hurdles, the tight site, the flooding risk, the moving sky bridge, the alarming tilt, and the bold copper facade, the American Copper Building emerged as both a piece of engineering genius and architectural art. It revived the concept of the sky bridge in New York for the first time in nearly 80 years and proved that even in one of the most crowded, expensive, and complicated cities on Earth, daring ideas can still rise above the skyline. Marina Bay Sands, Singapore's sky-high surfboard. Singapore's Marina Bay Sands isn't just a hotel, it's one of the most ambitious architectural experiments ever built. 3 massive towers rise from the reclaimed land of Marina Bay, and across their tops sits something that looks almost impossible. A giant surfboard-shaped sky park stretching longer than the Eiffel Tower is tall. Perched 650 feet in the air, it holds restaurants, gardens, observation decks, and the world's highest infinity pool, a pool so iconic that it seems to spill directly into the city skyline. But bringing this vision to life was a constant battle with physics. The land itself was a challenge, built on reclaimed soil that was soft, unstable, and prone to settling. To anchor the skyscrapers, Engineers had to drive more than 5,000 deep foundation piles into the ground, creating an underground forest of supports just to keep the towers steady. Then came the biggest question. How do you balance a sky park the size of an aircraft carrier across 3 towers? The answer required both audacity and precision. The sky park was constructed in giant steel segments, some weighing over 7,000 tons, and then hoisted into place by one of the heaviest lifts in construction history. One end cantilevers 66 meters beyond the edge of the tower with no support underneath, the longest public cantilever on Earth. To make it work, engineers had to install a system of expansion joints and flexible bearings so the park could shift with wind, temperature changes, and even small movements of the towers themselves. The pool itself created another nightmare. At 150 meters long, it stretches across all 3 towers. But because the towers naturally sway in the wind, the water at the edges would slosh violently if left unchecked. To prevent disaster, the pool was built in 3 separate sections, with hidden expansion joints and surge tanks that absorb water movement. That way, guests can float calmly at the edge of infinity while the skyscrapers subtly shift beneath them. Even during construction, dangers loomed. Hoisting the sky park's steel sections required flawless coordination. One misalignment and the entire structure could twist or crack. Workers labored hundreds of feet in the air, bolting and welding steel while cranes delicately nudged the massive pieces into place. Delays, budget overruns, and the sheer complexity of the project made many wonder if it would ever succeed. Yet against all odds, Marina Bay Sands opened in 2010 as one of the most striking man-made landmarks in Asia. Its 3 leaning towers and gravity-defying surfboard redefined what a skyscraper could be, transforming Singapore's skyline into something instantly recognizable around the world. What was once dismissed as impossible has become a symbol of engineering genius, where tourists now sip cocktails and swim above the clouds. Turning Torso, Sweden's twisting revolution. On the waterfront of Malmö, Sweden, rises a skyscraper that seems to defy gravity and geometry alike. The Turning Torso was the world's first twisting skyscraper, rotating a full 90 degrees from its base to the crown. Completed in 2005, it immediately became a symbol of modern architecture, but its daring form posed engineering challenges unlike any before. Designed by Spanish architect Santiago Calatrava and inspired by a human body in motion, the tower had to translate an organic sculpture into a functional, livable building. Divided into 9 stacked segments, each containing 5 floors, the Turning Torso twists gradually as it rises, creating a dramatic corkscrew effect. But twisting a tower introduces uneven loads and torque that could easily destabilize a conventional structure. To solve this, engineers anchored the building around a massive reinforced concrete core, while an external steel framework acts like a spine, distributing the twisting forces safely to the ground. Every floor plate and facade panel had to be custom-shaped and positioned with millimeter precision. Prefabricated concrete slabs were cast off-site and rotated into place one by one to maintain the spiral alignment. At 190 meters tall, the Turning Torso became Scandinavia's tallest building and the first skyscraper to prove that twisting architecture could work. Its bold design inspired a generation of spiraling towers worldwide, from Dubai's Cayenne Tower to Shanghai Tower. Here, on Sweden's southern coast, a radical idea became reality, a building that doesn't just reach for the sky, but twists toward it. Bosco Verticale, Milan's vertical forest. In the heart of Milan, 2 residential towers rise above the city, but instead of glass and steel dominating their facades, they're covered in something completely unexpected: trees. Known as the Bosco Verticale, or vertical forest, these twin towers host over 900 trees, 5,000 shrubs, and 20,000 smaller plants, transforming the skyline into a living ecosystem. The project was conceived as a radical solution to one of modern cities' biggest challenges: pollution. Each tower functions like a giant air filter. The vegetation absorbs carbon dioxide, produces oxygen, and helps reduce fine dust particles, improving air quality and cooling the surrounding environment. But turning skyscrapers into forests posed enormous engineering hurdles. How do you place fully grown trees hundreds of feet in the air without them toppling in strong winds? Engineers designed massive reinforced balconies to support soil, root systems, and irrigation while carrying the weight of the residential tower. Each tree is anchored securely, and wind tunnel testing determined the maximum height and weight for the plants. An automated irrigation system recycles water and channels it through drip lines, keeping thousands of plants healthy year-round. Maintenance required creativity too. Arborists rappel down the facades as flying gardeners to prune, replace, and monitor the vegetation. Completed in 2014, the Bosco Vertical became a global symbol of sustainable architecture. The towers provide homes for people and habitats for birds and insects, restoring biodiversity and creating an ever-changing urban forest that proves skyscrapers can heal cities, not just crowd them. 432 Park Avenue, New York's slim giant. Rising high above Manhattan, 432 Park Avenue isn't just another skyscraper, it's the world's skinniest super-tall tower. At 426 meters tall and only 15 meters wide per side, its extreme slenderness makes it an architectural marvel, but also a structural challenge unlike any other. Residents have reported hearing eerie creaks and groans as the building sways slightly during storms, a reminder that constructing a pencil tower in the heart of New York is no small feat. The site presented typical Manhattan challenges: a crowded urban environment, tight zoning rules, and sky-high land costs. Yet the main obstacle was the building's proportions. Slim supertalls are prone to swaying, and at this height, even minor movements can be noticeable. To stabilize the tower, engineers installed a tuned mass damper, a massive 400-ton steel pendulum near the top that absorbs vibrations, counteracting wind-induced sway and keeping motion comfortable for residents. Construction demanded extreme precision. The concrete core running through the center had to be cast with millimeter accuracy to prevent twisting or bending, and every floor plate was meticulously aligned to safely support the tower's weight while resisting lateral forces. Prefabricated concrete panels on the facade also required exact placement to ensure both aesthetic perfection and structural integrity. Completed in 2015, 432 Park Avenue redefined what's possible in urban high-rise design. Its slender profile, engineering ingenuity, and luxurious interiors turn structural risk into a bold aesthetic, proving that sometimes vertical ambition comes in the thinnest of packages. And Manhattan's skyline has never looked quite the same. Sky Habitat. In Singapore's Punggol district, Sky Habitat rises as a unique vision of urban living. Designed by Moshe Safdie, the same architect behind Marina Bay Sands, this residential complex consists of twin towers connected by multiple aerial walkways that create a vertical neighborhood in the sky. Completed in 2015, the project combines stunning architecture with innovative solutions for density, greenery, and community living. The design features sky bridges and sky gardens that link the towers at several levels, offering residents shared spaces with panoramic views of the city and surrounding landscapes. But connecting towers high above the ground introduced significant engineering challenges. Each walkway had to account for the natural sway of the towers, which move independently during high winds and storms. Engineers developed flexible connections and reinforced structures that allow slight movement without compromising safety or stability. The gardens themselves required careful planning. Heavy soil, large planters, and mature trees added substantial weight to the walkways, so structural supports were designed to accommodate both static and dynamic loads. Irrigation and drainage systems were integrated seamlessly to maintain the greenery year-round, turning the sky bridges into functional living spaces. Sky Habitat redefines high-rise residential design, offering both privacy and community in a densely populated city. By combining lush gardens, sky bridges, and innovative engineering, it demonstrates how skyscrapers can become vertical neighborhoods, places where residents live, interact, and connect above the city streets, bringing nature and urban life together in a harmonious, elevated environment. Cayenne Tower, Dubai's spiraling skyscraper. On the waterfront of Dubai Marina, Cayenne Tower spirals 90 degrees from base to top, making it one of the world's most visually striking residential towers. Completed in 2013, this 75-story skyscraper isn't just an aesthetic marvel. Its twisting design introduced a series of engineering challenges that pushed conventional high-rise construction to its limits. The concept was simple in theory, but fiendishly complex in practice. Each floor rotates slightly relative to the one below, creating a full 90-degree twist over the building's height. This spiral generates uneven loads and torque on the structure, which engineers had to carefully calculate and reinforce. A central concrete core absorbs lateral forces, anchoring the tower securely while maintaining stability and preventing twisting forces from compromising the building. Construction required extraordinary precision. Each floor plate is uniquely shaped, and steel supports were custom fabricated to match the spiral geometry. Wind engineering was critical. Dubai's coastal gusts demanded detailed modeling to prevent excessive sway or vibrations. Even interior layouts posed challenges. Apartments, plumbing, elevators, and utilities had to accommodate the rotation while remaining functional and safe. When it opened, the Cayenne Tower became an instant icon of Dubai's skyline. Its graceful twist isn't just a striking visual, it represents a triumph of engineering over extreme geometric complexity. Rising safely into the clouds while offering luxurious living spaces, the tower stands as a testament to architectural audacity and innovation, proving that even a spiraling skyscraper can achieve both beauty and practicality. King Power Mahanakhon. Dominating Bangkok's skyline, the King Power Mahanakhon stands out like a digital sculpture in a sea of conventional skyscrapers. Completed in 2016, this 314-meter-tall tower features a striking pixelated facade with irregular cuboid sections seemingly carved out of the building, giving it a glitching effect that's unlike anything else in the city. While visually dramatic, this pixelation created one of the most complex structural challenges in modern high-rise construction. The tower isn't a simple straight column. It's composed of two distinct volumes, a smooth outer skin and an inner core, interrupted by voids that twist and break the facade at irregular intervals. Each pixel had to be carefully engineered to avoid compromising the structural integrity of the building. Engineers employed a reinforced concrete core for stability, while the outer skin was supported by a steel exoskeleton that transfers loads safely around the missing sections. Construction was equally demanding. Every floor plate in the pixelated areas had unique shapes, requiring precise prefabrication and alignment. Cranes and hoists had to navigate around the voids, and each irregular section was carefully monitored to ensure it connected perfectly with the core. Wind engineering was critical as well. The perforated design created unusual air currents that could cause swaying, so computational fluid dynamics simulations were used to predict and counteract potential motion. The pixelation wasn't just for looks, it allowed for outdoor terraces and observation decks, giving residents and visitors breathtaking views of Bangkok. The tower also includes luxury residences, a hotel, and retail spaces, all integrated into the unconventional geometry. The visual effect makes the building look like it's dissolving or unraveling as it rises, an optical trick that's become a signature landmark of the city. King Power Mahanakhon exemplifies how bold architectural concepts can meet engineering ingenuity. By turning a facade into a dynamic pixelated sculpture, the architects and engineers transformed Bangkok's skyline, proving that skyscrapers can be both functional and visually revolutionary. Raffles City. Rising dramatically over the Yangtze River, Raffles City Chongqing is a skyscraper complex unlike any other. Completed in 2019, it consists of 8 towers, but the showstopper is a 300-meter-long horizontal structure, nicknamed the Horizontal Skyscraper, that spans across the tops of 6 of the towers. The effect is jaw-dropping. It looks like a massive bridge suspended in the sky, defying conventional notions of what a high-rise can be. The engineering challenges were enormous. The horizontal structure weighs tens of thousands of tons and is supported only by the vertical towers at either end. Any differential movement between the towers caused by wind, thermal expansion, or even seismic activity could stress the structure to catastrophic levels. Engineers had to carefully calibrate the core and foundation of each tower, ensuring that the horizontal skyscraper could float above them without transferring dangerous loads. Construction of the skybridge required innovative prefabrication and lifting techniques. Sections of the horizontal structure were assembled on temporary supports and gradually raised into place, then connected to the towers with massive steel joints that allow for subtle movement while maintaining rigidity. Wind tunnel testing and seismic modeling were essential to ensure the long span could withstand the forces of nature in this riverfront city. The horizontal skyscraper isn't just a visual spectacle. It houses sky gardens, restaurants, and observation decks, giving visitors panoramic views of the city and the river below. By connecting multiple towers at the top, it also distributes mechanical systems efficiently, allowing for shared amenities and infrastructure across the complex. Raffles City Chongqing pushes the boundaries of what's possible in vertical architecture. It transforms the idea of a skyscraper from a single vertical entity into a connected, dynamic complex, proving that sometimes the most audacious designs require equally audacious engineering. Today, it stands as a symbol of innovation, combining bold aesthetics with structural mastery on one of the world's most challenging urban sites. Shanghai Tower. In the heart of Shanghai's financial district, the Shanghai Tower rises to 632 meters, making it the world's second tallest building. Its elegant spiraling design isn't just for show. The tower twists as it climbs to reduce wind loads, a critical innovation for a structure of this height. Beyond its record-breaking stature, it also houses the fastest elevators on Earth, zipping residents and workers up at breathtaking speeds. Wind was the primary challenge. At such extreme heights, gusts can create enormous lateral forces that threaten stability. To counter this, architects and engineers designed the tower with a 120-degree twist along its vertical axis. The spiraling facade directs wind around the building rather than against it, reducing pressure by about 24% and lessening sway for occupants. Another hurdle was vertical transportation. Moving people efficiently across 128 floors demanded record-breaking elevator technology. The Shanghai Tower features double-deck elevators capable of reaching speeds over 20 meters per second, carrying hundreds of passengers simultaneously while ensuring safety and comfort. Engineers incorporated advanced damping systems and air pressure controls to minimize ear discomfort and vibrations. The building's design also prioritizes sustainability. A double-skin facade provides insulation, reducing energy consumption, while wind turbines and a rainwater collection system make it one of the most energy-efficient super tools in the world. Inside, the tower blends office space, hotels, observation decks, and retail into a vertical city that functions smoothly despite its immense scale. The Shanghai Tower represents the pinnacle of modern skyscraper engineering, a fusion of architectural beauty, cutting-edge technology, and practical innovation. Its twisting form not only defines Shanghai's skyline, but also sets a benchmark for how extreme height, safety, and sustainability can coexist in a single, awe-inspiring structure. Nakagin Capsule Tower. In Tokyo's bustling Shimbashi district, the Nakagin Capsule Tower once stood as one of the strangest experiments in skyscraper design. Completed in 1972 and sadly demolished in 2022, the 13-story tower was a modular marvel. Each floor contained small, removable capsules that could be individually replaced or updated, creating a living, adaptable structure unlike anything else in the world. The concept was revolutionary. Architect Kisho Kurokawa envisioned a tower that could respond to the rapid pace of urban life, where residents could literally swap out living units as needs changed. But implementing this idea came with extreme technical challenges. Each capsule had to be self-contained, including plumbing, electrical connections, and structural supports, while also being light enough to be lifted and attached to the central core. The tower's construction was equally unique. A central reinforced concrete core provided stability, while the capsules were prefabricated off-site and bolted onto the core with massive steel connectors. Precision was crucial. Even a small misalignment could compromise the entire floor. Maintenance was another hurdle. Over time, the connections and utilities degraded, and many capsules became uninhabitable, contributing to the tower's eventual demolition. Despite its practical challenges, the Nakagin Capsule Tower remains an icon of metabolism, an architectural movement that sought to create dynamic, flexible structures for rapidly growing cities. Its striking modular design influenced architects worldwide and remains a symbol of daring experimentation in urban housing. The tower may no longer exist, but its legacy endures as a reminder that skyscrapers can be more than static monuments. They can be living, evolving systems designed to adapt to human needs. That's all for today. If you enjoyed exploring these incredible feats of architecture and engineering, make sure to like, share, and subscribe to our channel for more amazing videos on the world's most fascinating buildings. Don't forget to hit the bell icon so you never miss an update.